Okay, we're going to use a special substitution to solve or to evaluate the integral of the square root of x squared minus 9 over x with respect to x. So looking at this, I can go straight into our special substitution, because if the thing that you want to integrate, so if it contains a root x squared minus a squared, you should try substituting x equals a sec theta. X equals a sec theta. So here what we have at the top, we have a root x squared minus 9. So we have root x squared minus 3 squared. So if you compare that to the x squared minus a squared, well, the a is 3. So we will substitute x equals 3 sec theta. So that's how we begin. So now we're going to have to transform this integral, and what we're going to need an expression for dx. So I'm going to differentiate this with respect to theta. So dx by d theta equals, so you may not remember this, but you don't need to. If you have your formula book to hand, you should know that sec x, the derivative of sec x is sec x tan x. So the derivative of sec theta is sec theta tan theta. So the derivative of 3 sec theta is 3 sec theta tan theta. So 3 sec theta tan theta. And remember, we don't need to prove this. We're just using standard derivatives that are written in the formula book. It's not a difficult one to prove, but there's really no need to do it right now. Okay, so that must mean that dx equals 3 sec theta tan theta d theta. Okay, so now we're looking to transform this integral into something good. So now the transformed integral equals, so the integral of, so we know that x equals 3 sec theta. So we have here the square root of x squared, so that must be 3 sec theta squared. So 3 sec theta squared minus 9 over, well, it's over x is 3 sec theta, and then dx, well, dx we've just said is 3 sec theta tan theta d theta. Tan theta d theta just about fits. Okay, so good start. We can look at the 3 sec theta here and the 3 sec theta here, and we can cancel 1 1. Okay, so that's not bad at all. Then there's not much else we can do yet, so what we are going to do is expand that bracket. So 3 sec theta squared, and see where we get to with that. So equals the integral of square root, well, 3 sec theta all squared is 3 squared times sec theta squared, which is 9 sec squared theta. 9 sec squared theta minus 9. This has gone, so you've just got times a tan theta d theta. Okay, so there is a common factor in there of 9, so I'm going to pull that out and hope that something good happens. So I'm just going to use the one more line here. So equals the integral of, so the square root, and I'm just going to pull it out. So 9 sec squared theta minus 1 tan theta d theta. Okay, right, 2 things. So the first one is that you've got a kind of you can use your laws of surd, so I'll probably do that first actually, and then the second thing is going to be looking for an identity, so we can write this sec squared in terms of tan squared. So let's start by dealing with this 9. So you've got the root of 9 times sec squared theta minus 1. So using your one of your laws of surds even, you can write that as root 9 times root sec squared theta minus 1. So equals the integral of root 9 times root sec squared theta minus 1 tan theta d theta. Okay, so the root 9 is 3. Now I'm going to take you back to the formula book, and if you look at the useful identity or the trig identities, the Pythagorean identities, one of them says that 1 plus tan squared theta, or it says x, but we're going to put theta, equals sec squared theta. So a simple rearrangement of that says that tan squared theta equals sec squared theta minus 1. So this is quite handy. So we can substitute. So substitute tan squared theta in for sec squared theta minus 1 because they are exactly equivalent. The root 9 is 3, so this here is going to be 3 times the square root of tan squared theta. So equals, so now our integral equals root 3 times the root of tan squared theta times tan theta d theta. So now we have the square root of tan squared theta is tan theta. This tan theta times the other tan theta is tan squared theta. The 3 is still there. I'm going to pull that out. Equals 3 times the integral of tan squared theta d theta. And you're thinking, well, we're nearly there now. But unfortunately, if you look in your formula book, it doesn't actually have a standard integral or a standard derivative that goes to tan squared theta. So what we're going to do actually is we're going to go back to this Pythagorean identity again, and I'm going to get this in terms of sec squared, which I do know how to integrate because it's in the formula booklet as a standard derivative. So we know that tan squared theta is sec squared theta minus 1, so I'm going to put this in again. So equals 3 times the integral of sec squared theta minus 1 with respect to theta. Right, so now, again, hopefully remembering it, but otherwise looking at your formula sheet, your formula booklet, you should know that tan theta, or tan x, differentiates to sec squared theta or sec squared x, depending on what your variable is. So integrating, going the other way, well, sec squared theta is going to integrate to tan theta with respect to theta, minus 1 is going to integrate to theta with respect to theta. So this is 3 tan theta minus theta plus the constant of integration. That is a 3. So 3 tan theta minus 3 theta plus the constant of integration. So that, in terms of theta, this is finished. Unfortunately, we're still not finished the question because we need to get this thing in terms of x, not in terms of theta. So I'm going to leave this space here to do a bit of work on that, and hopefully we can just write the answer in here. So now we go back to our initial x equals 3 sec theta, and we need an expression for 3 tan theta, and we need an expression for minus 3 theta in terms of x, and we're going to start here. So x equals 3 sec theta. Well, you know that sec is 1 over cos, so that kind of, well, x over 3 equals sec theta. Well, sec theta is 1 over cos theta. If we take the reciprocals of both sides, then that says that cos theta equals 3 over x. So cos theta equals 3 over x. Okay, so from there we can quite easily get an expression for theta. So that means that theta must be the inverse cos, the arc cos. Theta equals arc cos. 3 over x. So that will be good enough to substitute in for the theta. We still need an expression for tan theta, which is the awkward bit. So what I'm going to do, I'm going to use this information that cos theta equals 3 over x, and I'm going to draw a triangle. So something like that. Right angle triangle, theta. And we know that cos theta equals 3 over x. So you have an opposite side, adjacent side, and a hypotenuse. Cos is adjacent over hypotenuse. So cos theta equals this over this. Cos theta is 3 over x. Right, so if that's cos theta, I need an expression for tan theta, which is opposite over adjacent. So it's going to be this, something over 3. But the something we can get by using the Pythagorean identity again, so well, just the Pythagoras theorem, sorry. So this is a short side in a right angle triangle, so it's going to be the square root of c squared minus b squared. So this is the square root of long side x squared minus 3 squared, well that's 9. So that means that tan theta must be opposite over adjacent, so it's that over 3 equals root x squared minus 9 over 3. So now we're nearly there. I just need to now put this in. So I reckon 2 more lines and we'll be there. So equals 3 tan theta is square root x squared minus 9 over 3. So 3 tan theta. And those 3's are going to cancel nicely. Minus 3 theta. Well, theta we've just said is arc cos 3 over x, so that must minus 3 arc cos 3 over x plus the constant of integration. So our final answer, just taking into account this cancelling, equals square root of x squared minus 9 minus 3 arc cos 3 over x plus the constant of integration. And finally, we are here. So the integral with respect to x of the square root of x squared minus 9 over x is square root of x squared minus 9 minus 3 arc cos 3 over x plus the constant of integration.